It's always good to see people experimenting with the older models with new twists. In this video, we will be looking at this new project called as GPT-2 with native audio generation. What this person has done is that after getting inspired by Andrei Karpathy's latest Let's Build GPT-2 series, he trained a GPT-2 model to generate audio. And it's not really, of course, a production grade project, but for the learning purposes and how you can use these models to embed audio or multimodality into it, I think it's a very good learning exercise. I would highly suggest that go through this GitHub repo, and I'm sure you'll learn a lot. So I will drop the link to it in video's description. In this video, I will be sharing with you a Colab, and we will be running it to do the inference with this newly fine-tuned model, which it is called as GPT-2 Audio Tiny Sherlock 5K Overfit. Seems really interesting. Also, um, technical side of things, he didn't add anything to the GPT-2 architecture because he just wanted to keep everything as is. And data set was also quite small, but it was diverse enough to make sure that this works. Okay, so let's try it out, and let me take you to my Google Colab. It's a free version. Go to runtime and change runtime type to T4 GPU. That is done. Let's git clone that repo. And as I said earlier, I'm going to put the link to it in video's description. So let's cd to the content and git clone this repo. Not that big repo, so should be fairly quick. Git is cloned now. Let's also install all the requirements. So I'm simply running the usual pip install requirement.txt, and it is going to install all the prerequisites from the repo. And you can see that it is installing a lot of stuff, including INOPS, which is used for tensor manipulation. Let's wait for it to finish. All the prerequisites are done. Let's open a new cell and cd to that directory. Make sure that you are in this build nano GPT-2 directory. And then from Hugging Face, let's download the model, which I just showed you, this tiny Sherlock one. So let's wait for it. And it's not a huge model. You see, it's just very tiny 397 parameter model. It's really good to see that such a small model was tuned on this audio data set. Okay, so let's import some of the stuff from the GitHub repo, which we have cloned. And you see that we are simply importing the GPT-2 inference and all that stuff. NumPy, I think it's already installed. Yep, so NumPy is there. And now let's check if we are using GPU or CPU. So you just need to set your device to either CPU or CUDA for GPU. Okay, let's wait for it. So if we are using CUDA, so that is all good. And now let's instantiate our model, and then let me actually paste it, and then I'll describe what is happening here. Let me open a new cell, and here we are just instantiating this GPT. Then we are setting our model here, and then we are setting the correct dictionary, setting the device, obtaining the tokenizer, and then getting the value out. Let's run it. It is just going to get the model for the PyTorch one. It won't take too long, and that is already done. Okay, so and now for the context and stuff, let's set it up with the cache. Let me paste it, and then I will describe what exactly is happening here. So here we are just putting in the separator. So separator is just a delimiter, and then we are setting the context. We have just set the context to 4097, and then we are manipulating the tokens with our PyTorch library. And from here, this tqdem is setting for the progress bar, and then we are looping through some of the variables around probes and then output probabilities, logits. And if you don't know what these logits probes are, I have done detailed videos on them in very simple language, so please search the channel. And then from here we are simply looping through the xgen. So let me run it. Shouldn't take too long. It is running, as you can see, with the multinomial stuff. and here it is downloading it. Let's wait for it, and this is a TQTM showing you the progress bar. Shouldn't take too long, and it also shows you the ETA here, which is around just under 4 minutes, and it could go up and down as per your internet speed and your GPU speed. And as you can see that the sample generation is taking a bit of a time. It's already more than 9 minutes and still 7 minutes remaining. It is 71% done. So let's wait for it to finish. If you're using a good GPU, then it won't take that long. Anyway, so nothing we can do about it but to wait to get all the samples generated. Samples are almost done, and you can see that it has taken it around 19 minutes or so. So you have to be patient with it, especially on this free GPU that is done. Okay, let's try out few of the samples. So I'm just checking the first sample 0, and we are decoding it with a tokenizer, and let me play the audio first.
Hand in hand,
There you go.
hover over this great city, gently remove the roofs
I will let it play.
and peek in at the queer things which are going on. The strange coincidences, full chains of events working through generations.
Okay, so you see the quality is not that good for the 01, but remember it is just GPT-2, and then it's a very small data set, but still not bad. Let's try out sample 1. I will also try to increase the sound. Let me generate it first, and then I will then play around with it. That is done. Let me play it.
Power would rise to the level of intuition until those who are unacquainted with his methods would look askance at him, as on a man whose knowledge was not that of other mortals. When I saw him that afternoon, so enwrapped in the music at St. James's Hall, I felt that in
So this one is much better. Let's try out another one. The decoding. Let me play it a bit.
I found the den of which I was in search. Ordering my cab to wait, I passed down the steps, worn hollow in the centre by the ceaseless tread of drunken.
So you see that just by using these commands, you can train your model, you can do the inference on any data so that it will convert it into audio. I will drop the link to this repo, and also you can access the Colab from here, run it on your own T4 GPU. You can even use your own dataset if you like, but of course you might have to do a bit of a training too. And if you're looking to train your own model, you can also find some of the commands in this GitHub repo, but you would need a better GPU if you are looking to do the training or fine tuning. That's it. I hope that you enjoyed it. Let me know what do you think. If you like the content, please consider subscribing to the channel, and if you're already subscribed, please share it among your network as it helps. Thank you.